Hello students. Today we are going to derive formula for false position method. This method is also known as regular falsy or method of linear interpolation. This method is very much similar to bisection method but faster than it. So how we are going to derive a formula? First, we are taking the points on the x and y axis. Say suppose we are having 2 points x1 and x2 between which the root of a nonlinear equation lies. So this is our x-axis and this is our f of x function defined on this x-axis. Now here we are having the point x2, here we are having the point x1. Let us try to join these 2 points through a straight line. So when we are joining this through a straight line, this line will intersect the x-axis at a point. So let that point be x3. This x3 will be our new considered point. Now the point here will be x2 comma f of x2 because the coordinates of this point will be x2 comma f of x2. x2 is this intercept and f of x2 is this. Now similarly the point here will be equivalent to x1, the intercept of x1, and f of x2. Now when we join both of these points, they will intersect at a point which we say that it is the next point x3. So we have to calculate the formula for calculating x3 value. Now how we are going to do this? We will consider a slope. Now how we do it, like we will first of all consider the slope of a line joining the point x3, 0. We'll again show here this point will be equivalent to the coordinates of this point will be equivalent to x3, 0 because here f of x intercept is 0 on this line. So therefore this point will be equivalent to x3, 0. Now first of all we will calculate the slope of this line from this point to this. Then we will calculate the slope of this line from this point to this. As you know, then the slope of a straight line is equal. Then therefore we will say that the slope from this point to this point and the slope from this point to this point will be equal, and therefore we will calculate the formula for x3. So how we are going to do it? So slope of a line joining the points x3, 0 and x2, f of x2 is given by tan theta is equal to f of x2 minus 0 divided by x2 minus x3. As you know, the slope of a line is given by y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. But in our formula, in our graph, we have this as our x2 and this point as our x1. So therefore it will be equal to f of x2 minus 0 because here the x is the y-intercept will be equal to 0. F of x function on this point will be equal to 0. Therefore we say that tan theta is equal to f of x2 minus 0 divided by x2 minus x3. Similarly, the slope of a line joining the points x1, f of x1 and x2, f of x2 is given by tan theta is equal to f of x2 minus f of x1 divided by x2 minus x1. As you know, the slope of a straight line is equal at any point, therefore this will be equivalent to this. So Since the line joining the point x3, 0 and x2, f of x2 is a part of the line joining the point x1, f of x1 and x2, f of x2, therefore f of x2 divided by x2 minus x3 will be equivalent to f of x2 minus f of x1 divided by x2 minus x1. Then when we will solve it for x3 value, it will be equal to x3 will be equal to x1 f of x2 minus x2 f of x1 divided by f of x3 minus f of x1. Here what we are doing, we are just solving it for x3. Therefore our new point will be equivalent to x3 is equal to x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. In the bisection method, what we were doing is that we were calculating x3 as equivalent to x2 plus x1 divided by 2. Here we have to calculate the next point x3 as x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. So in our next lecture, we will take an example and try to solve the nonlinear equation through regular falsy method or false position method. Thank you.